Okay, so let's look at some examples of quadratic equations where I'm not actually necessarily looking for the solution. Like I don't necessarily care what x is, but really I'm more concerned about how many solutions. So regardless of what x could or couldn't be, how many possible solutions could I have to this equation, for example, okay? And there's a quick way where I can check that, and it involves the quadratic formula. So from our previous lessons, we know that ax squared plus bx plus c equals 0 can be solved by using the quadratic formula, where I can calculate the value of x by just saying I have negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so when I look at this equation, I can plug these numbers in to figure out what x is, but really if I'm concerned with how many solutions, I really only need to focus on this part, the b squared minus 4ac. I really just need to focus on this part of the quadratic formula. Okay, and I'm going to show you why. So let's say I go and I plug a, b, and c into my quadratic formula. So that means that a would be equal to 5, b is equal to negative 8, and c is equal to positive 6. So if I just focus on b squared minus 4ac, that means that I will have, so b squared minus 4ac, that would mean that I would have to have negative 8 all squared minus 4 times a equals 5 and c equals 6. Okay, so that means that I would get 64 take away 120. When I take away 120 from 64, I get negative 56. Okay, so because so if you notice, I didn't look at any other part of my quadratic formula. I was just focusing on the b squared minus the 4ac, which is called the discriminant, and it is negative 56. Now, I know that when I take the square root of a negative number, what's going to happen? I'm going to get something that is undefined. And if it's undefined, that means that if I'm trying to solve this formula, if I'm trying to figure out what x is, as soon as I see this negative number, I know that I'm not going to get a proper solution. It doesn't make any sense. In the middle of my expression, I've got this square root negative 56. So that means my whole entire expression, that negative b plus or minus square root b squared minus 4ac over 2a, none of that really matters because the radical has a negative radicand, and that is going to give us problems. That is undefined. There's no possible solution. So this equation actually has no solutions. So I didn't focus on any other part of the quadratic formula, just that b squared minus 4ac. As soon as I saw that it was negative, I know that I have no solutions. Okay, so that means if I say how many solutions, well, actually I have 0 solutions. That means that I have no real roots, and I can also use the word zeros that means I have no zeros either. Okay, so I have no real roots and I have no zeros. Now, if I go and I look at something a little bit different, okay, so let's say I have 2x squared plus 9x take away 2 equals 0. So let's say I'm looking at this equation, and I say, okay, how many solutions exist here? How many solutions? How many solutions? Okay, so again, all I have to focus on is that discriminant, which is b squared minus 4ac. Okay, so in this case, a is equal to 2, b is equal to positive 9, and c is equal to negative 2. So if I plug in these numbers, I'm going to get 9 squared minus 4 times A is 2, C is negative 2. When I go to plug this in, I get 81 add, because I'm taking away 4 and then I'm multiplying it by a negative number. I get 81 add 16. And that's going to make my discriminant or that expression underneath the radical, that's going to make that number 97. So I don't really care even about the rest of it. I know that when I go to plug, when I go and I substitute my A, B, and C into the quadratic formula, I'm not too concerned about this. I just know that this number is going to be 97. So that tells me that the two potential solutions I could have is one where I have, we can just do it. This is 9, right? And then A is equal to negative 2. So I know that I have two solutions because when I go and I plug in these values, I'm going to get negative 9. I'm going to get a solution where I'm adding root 97 over 2 times negative 2, which will give me negative 4. And then I also have this situation where I'm taking away root 97. So that results in 2 solutions. Okay, so if you notice, here's my number 97, and that was greater than 0. Okay, and I got 2 solutions. Here, when I did this earlier, here my discriminant, my b squared minus 4ac, this here is a negative number. This was less than 0, and I got no solutions. Okay, so when this guy is less than 0, which means I'm going to get a negative number, I get no solutions because my radical is undefined. When I have something that's greater than 0, b squared minus 4ac is greater than 0, then I get this positive radical, this square root 97. And that means that I'm going to have to add it and subtract it from whatever negative b is in my numerator. So that means I will generate 2 solutions. Okay, so you can have 0 solutions or you can have 2 solutions. And again, I could say something like, this generates 2 real roots, or this has 2 zeros. Okay, so again, I can use that language to describe what's happening there. But now let's take an example where perhaps something a little bit different is happening. So let's say I have 3x squared minus, minus 6x plus 3. Let's do that. Equals 0. Okay, so here A is equal to 3, B is equal to negative 6, and C is equal to positive 3. So now when I go and I look at b squared minus 4ac, and I substitute these values in, I get negative 6 squared minus 4 times 3 times 3. Or sorry, negative, oh no, that's not negative, that's fine. Okay, so now I get 36, take away, 4 times 6, times 6, 4 times 9 gives me 36 as well, okay? So now I have a situation where this guy equals 0. And now, so when I go to calculate what x could be, I have my negative b plus or minus the square root of 0 over 2a. But if I have the square root of 0, that means that this expression or this radical literally just disappears, which means I'm only left with negative b over 2a. I'm not adding or subtracting anything. So this here generates it generates only one solution. So here I only get one solution, okay? And this time my discriminant, my b squared minus 4ac, is actually equal to 0. Okay, so it equals 0. So let's take a look here. When I have my b squared minus 4ac, when it's less than 0, when it's negative, when this is going on, I get no solutions, okay? Because I have something that is undefined, that's not gonna work. There is no value of x that exists to make this equation equal to 0. When my discriminant, my b squared minus 4ac, when it's greater than 0, like this, okay, when it's greater than 0, then I end up generating two solutions because I have this radical, this root 97 in this particular example, but that would happen every time. I have this radical that I'm adding to my negative b value in the numerator, and that I'm also subtracting. Okay, so I get two solutions: one where I'm adding, one where I'm subtracting. And then the last case is one where b squared minus 4ac actually just equals 0. In which case I'm not adding or subtracting anything. All I have is just negative b over 2a. And in this case, we could even calculate this number. If you want to, you'll end up getting negative 6 over 2 times 3, which actually just ends up being positive 6 over 6. So actually my x is equal to 1 here. And what that means is that I have one solution. Okay? So I hope that these three scenarios inform you about the relationship between the discriminant. And by the way, we use the word discriminant because if you notice the discriminant, it discriminates against how many solutions we're going to have. And there's really only three possibilities. A scenario where we have no solutions, a scenario where we have two solutions, and a scenario where we have exactly one solution. So you can use the discriminant to help you decide how many solutions you'll have when you're using that quadratic formula and trying to solve quadratic equations.